To GIS Madras. In this video tutorial, I'll be showing you how to calculate drainage density map using ArcGIS. So basically, you require two data. One is stream file and one is boundary file. The boundaries refer to it may be a watershed, basin, sub-watershed, etc. So now let us add the data first. So I'm going to add the stream data and watershed data here. So this is the view of the datasets which has been used. So let me show you the attribute table of these layers. First, let me open the stream. You can find a stream order and stream class. So this stream class is not required. So stream order is required for this. And let me open the attribute table and show you. This is how the attribute looks like. So the first step will be projecting the watershed and stream to the local projection. So you can see here. The first step is project layers to local projection using our toolbox. Now go back to the ArcGIS. Now here go to the Arc toolbox and go to the option data management tools. Come down, you can find the option projection and transformation. You click on the plus button and in the down you can find the option project. Double click and select it. So let us first input the stream data. So I have inputted the stream. You can see the input coordinate system, that is WGS 84 1984, and here you can see you can set the new projection system. So I'm going to use the projected coordinate system UTM WGS 1984 Northern Hemisphere. So this is a local projection for the stream and watershed. So I'm using the projected coordinate system because we are going to calculate the length and the area for this layers. So we require the projected coordinate system. You can see the output data or feature class. You can set it. So here I'm going to give a name for it, pro stream, nothing but projected stream. Save, click OK. Now it has been started processing. So now you can see here it is being successfully completed. And go back to the Arc toolbox once again, project. This time we are going to select the watershed and select the output. So here I'm going to use watershed as the output name. Save. Once again we need to specify the output coordinate system. So go to the option projected coordinate systems and select UTM and come down to the option WGS 1984 and Northern Hemisphere. So this is the local projection which I'm going to use. Once again 44 and click OK. Now click the option OK and it will be completed within few seconds. So we have successfully projected it to the local coordinate system. Now let me click on the table of contents and let me remove the watershed and pro. Finally I need to add the streams which has been projected. Pro stream. Yes, we have added it. We just move back to the next step. And the next step is creation of grid index for the basin or watershed and sub-watershed area. So go to the ArcGIS interface. Once again go to the Arc toolbox and select Cartographic tools and here select data driven page and here you can find the option grid index features. Double click and open it. And you can see we are going to use kilometers as the units. So I'm going to create a 4x4 grid. So I'm going to create a 4x4 grids. So in the environment section, let me go to the output coordinate system. So I'm going to use the layer same as pro watershed. So I'm going to get the output projection as the PCS local projection system, which have we projected to the stream and watershed previously. Now click OK and once again click OK to begin the process of creating grids. So Using this tool, we are going to create grid index feature. First, we are going to select the output location. So let me name it as grids and hit the button save. Now here I am going to use the watershed for creating grids. Come down. Here the polygon width will be 4, so it's a 4 by 4 polygon. So the units will be in kilometers. Now click OK in order to begin the process. So we have successfully created a grid. Now we are going to clip it. Clipping is the next step, as you can see in the Word document. So we're going to clip the grids using the watershed boundary. So now go to the option geoprocessing. Here you can find clip. Open the clip tool. Our input feature will be grids and our clip features will be Pro watershed, that is projected watershed. Choose the output location where we have to save it. So I have named it grids clip. Hit the button save. Here in the XY tolerance, select meters. In the environments, select output coordinate system. Here I am going to choose same as Pro watershed. So it will be automatically reprojected to the local system. It will be much easier for calculating the area. So now click on the option meters. Now click the option OK to begin. So we have successfully clipped. So going back to the Word document, here the next step is intersect tool. So it computes a geometric intersection of feature inputs. The features or portion of features which overlaps in all layers or feature classes will be returned to the output feature class. So let me show you how it works. So select Arc toolbox and select analysis tool and select overlay tool. So in that you can find intersect. Double click and open the tool. So let me minimize and show you how it works. Now let me remove the grids. So you can see that we have clipped the grids, and let me show you the attributes. So you can see page number, page name and page number has been there. So using the intersect tool, what we are going to do is that we are going to extract this grid information. So this grid information will be stored to the that is stream files. The grid information will be saved to the stream files. So that we'll be seeing it how it looks like. Now let me first input the streams, and after that I'm going to select grids clip. Now I'm going to select the output location. Let me save it as intersect. Save. And once again go to the environments option. Here the processing extent I'm going to select the stream, pro stream. Sorry, I was just so it should be output coordinate system. Here we are going to choose the pro stream. So you can see here I am just using same projection. Click OK. Now it will be in meters. Now click OK to begin the process. So the intersect has been successfully completed. Let me show you the attribute table of the pro stream file. So you can see only a stream order was there. Now let me open the intersect file and show you the difference. So you can find the stream order grids, page name and page number. So we have got the information from this grids to this stream file, that is intersect file. Going back to the Word document once again, here the next step will be dissolve. So we are going to dissolve the fields, the field or fields on which to aggregate the features together. Go back to the ArcGIS, select Arc toolbox. So let me close the previous tools. So under the data management tools, you can see the option generalization. So open the generalization, you can find the option dissolve. So we are going to dissolve. So our input will be in the intersect, so which is also this stream file. So we are going to dissolve based on page number. So we are going to use page number for dissolving. In the attribute table, you can see the option page number 24, 25. So we are going to dissolve it based on the page number. So if features which is in 93, for example 93, will be joined together as a single 93 file. So that is what dissolve file does. Finally select the output location. Hit save. In the environments, once again choose the output coordinate system as same as ProStream. Click OK and once again click OK to begin the process. So we are done with the process of dissolving. Now let me show you the attribute table, how it looks like. You can see it has been combined together. So let me remove the intersect file and grids file so that it won't be getting confused. Now we are going to calculate the length of these streams. Open the attribute table and here add a field and name the field as length. We are going to select double, click OK. Now left click on it and for selecting it and right click, and you can find the option calculate geometry. Select geometry, click S. So here you can see we are using the projected coordinate system. Here you can select. So here I am going to use kilometers as the length of units. Now click OK. Yes. So we have got the measurements of the each stream length. Once again right click and you can see the option properties here. Here in the option numeric, I am going to choose 3. Click OK. Apply. Now you can see here. So we have calculated the length of the streams, and now we are going to combine this watershed, that is the grids, with the intersect tool, that is stream. Now for that select the grids clip and now go to the option open attribute table, and here you can find the information, page number, page name and all. Now once again right click on it and go to the option join. Select join. Here you can choose the file accordingly. Here I'm going to use the intersect dissolve, and the common file will be page number. As you can see here, page number. Automatically both this file will be combined together. Let me click OK. Yes. Now let me open the attribute table of this grids clip. It will be updated. You can see the length has been come up, page number has been come up from the intersect file, that is a stream file. So now in order to save it, right click on this layer and go to the option data and select export data, and here choose this option browse, and here you can rename the file and save it. Click OK, and yes, I need it in the app to be added. So now let me remove the grids clip, row watershed, row streams. Only these two files will be there. Now you can see the attribute table of this file. You can find the length, page number from the intersect dissolve, that is stream. It has been brought up here. Now once again we are going to create another field. Here we are going to use, or we are going to give the name as area, and select double, click OK. Once again we are going to calculate the area for this grids. Now use geometric calculator, calculate geometry. Yes, here I am going to use square kilometers. Now click OK to begin. Yes, so we have calculated the area also for this file. The final step will be calculation of drainage density. Going back to the Word document, here we have joined it. We have calculated the area for the grids. Now you can see drainage density is expressed in units. The length divided by the kilometer area. So we have already calculated the length and kilometers, area kilometer, length of the stream and area of the grids. We have already done it. So this is the formula. So let me show you how to do that. The basic formula is you can see here, drainage density is nothing but the length of the stream divided by the area. Go back to the ArcGIS. Here in the DD, open the attribute table. Once again create a new field, name it as DD, select double, click OK. So now click, that is left click, and once again use the right click and select the option field calculator. Click yes. Now you have already know the formula. First we are going to put the land and divide it by the area. Now click OK. So we have got the drainage density. Successfully we have got the drainage density. You can also visualize it. Right click on the DD, go to the option properties. Here you can find the option symbology, and select quantities. Here you can choose any among the following. Let me choose the value, DD value. You can see here. So you can see here the drainage density. You can just give the color accordingly. Let me click apply and OK. You can see how it looks like. If you want, you can also label it. Label features, and once again go to properties. Here in the label you can select DD. So I'm going to select DD, click apply and OK. Likewise you can do. You can also use the IDW technique for preparing a much more wonderful maps. So let me go to the Arc Word document. Here you can, after calculating the drainage density, The 10th step is features to point. There's a tool for it. In the search, you can use this button for search the tool. Features to point. You can see features to point. Open this tool. So the input feature will be DD, and you can choose the output location as well. So it will be saved in point. So let me explain you how this tool works. So actually, from this shape file, you can see a lot of grids is there. So for each grid, a point will be created. You can use it for interpolation. Don't forget to select this option. Inside, we are going to create the polygon inside this grids. Click OK. So now you can see here the points has been successfully created. So now we can use these points for running IDW. So once again, click on the search, and here select type in IDW spatial analysis tool. Double click and open the tool. So here we are going to input the points, DD points. So Z value will be our DD value. You can choose the output location, whichever. Select environments. Here I am going to choose the output coordinates, same as Sub-watershed, and come down. You can see the processing extent. Here I am going to select the Sub-watershed layer, and the raster analysis I am going to use the mask. Same, I am going to use Sub-watershed. Now click OK, and finally click OK. If you want to save it to a custom location, you can by clicking this option you can do so. Now click OK to begin the process. So the result has been come out. Let me remove the DD file. You can see here how the results look like. Now go to the right click and go to the option properties. Here you can change the colors symbology. So I'm going to choose a different color scheme for this one. I'm going to use this scheme, and I'm going to choose 6 classes. 3. Okay. So you can see here, this is how it looks like. And you can see the values are very minimal, so it is lesser than 1, and it can be said as extremely low density or very coarse density. So if you have any other doubts in this, you can just ask in the comment section. Thanks for watching. Goodbye.